All right, welcome back to 164. Today, too, has nothing to do with Angry Birds, but just out of curiosity, is anyone here among the 10 million people that downloaded it this weekend? I was. I've wasted a couple hours already. So it's available for 99 cents, and it also exists apparently on Macs and maybe Android, too? Maybe not. No. Yes? OK. All right. Anyhow, completely unrelated. Speaking of games, though, I thought it might be fun to play a round or two of Evil Hangman. So here we actually have my own implementation of this. Yours does not need to look exactly like this, but it does, of course, have to be consistent with the specs. So here we have my implementation. I've queued it up for a 4-letter word, and down below the blue bar, you can see what letters we haven't yet guessed. So can I have a letter, please? A. OK, I'm guessing A. Incorrect. E. Incorrect. I. R. OK, you messed up the pattern. All right. I heard H. I heard O. Ooh, nice. S. Moop. Does anyone know what that actually means? OK, so that was Evil Hangman. Let me go ahead and there's no high scores since we haven't yet won. Well, I mean, when you put in a dictionary of 214,000 words, it's a pretty big vocabulary. So when you play against your roommates, you might want to queue up a smaller dictionary. For instance, on the projects page of the course website, we actually put a small .plist file, which actually just has some words from the spec. But you could absolutely add to that things like cat and dog and puppy and whatnot, so as to really mess with your roommates. But let's turn evil off and go ahead and back to the front here. Start a new game, 4-letter word. F. You. I heard E. A. S. Oh, non-evil hangman's pretty hard too. Okay. Now, all right. So anyhow, we lost twice. But that is Evil Hangman. And if you're struggling, I thought I'd give you a little teaser of what my code looks like here. So this is my implementation. All right. So without further ado, a bunch of fun things on the agenda today that should hopefully help you as you also start thinking about what you want to do for your student choice project, which is the 4th and final for the course. So today we'll look a bit more at views and the general hierarchy of an MVC type application in this environment. The notion of localization, which is too often underappreciated by startups, especially when you're first starting out. It's sort of natural to start coding things in the language with which you are most familiar. And I don't mean programming language, I mean English. But it's actually super easy in a lot of languages, Objective-C among them, to actually internationalize your application so that it's super easy to add English and French and Spanish and Chinese so long as you actually have access to people who speak those languages and can help with the translations. We'll look at storage, some of the means by which you can actually save information persistently in an iOS device. Gesture. So thus far, we've pretty much just tapped on the keyboard, but you can pinch and scroll and zoom and so forth on these devices. So we'll give you a sense today of how to do that, and also how the implementation of that relates to some fundamental design patterns, among them delegation, which we've seen before and we'll continue to see. And then also we'll take a look at some 2-dimensional core graphics, so that for your 4th project, if you would like to do something a little more graphical and a little less UI kit based, which are the little widgets that you can drag and drop into an app, you can go that direction as well. So here's a picture that might hopefully give a sense, certainly as you dive into project 2, as to how everything works in an iOS application. So you do have your main routine. So we start up here at top left. The user taps some icon, and main is the same function that's executed. But as we just saw, there's really not much in there. And in fact, you should never really put anything in there yourself, because it immediately calls UI application main, which is part of the iOS SDK. And that kicks off the much more interesting process of running these apps. Load main UI file is apparently one of the first things that happens. But what does that actually mean? What is a UI file so far as we've seen? What's it referring to? So it might be referring really to a nib, the thing that you create within Interface Builder, a nib file, a .xib file. Or today, we'll see that you actually don't need to use this drag and drop interface. You can actually implement your user interface entirely programmatically. And indeed, that's what some folks do, either for religious reasons or simply for the flexibility of it. Finally, initialize the app. This can take the form of any number of methods, but we'll see some of the common paradigms today. Once the app moves into the foreground, let me scroll down here, it's this circle that pretty much governs these mobile applications. They just sit there in a loop, not quite an infinite while loop that's just there throttling itself again and again, but listening every few milliseconds or every few microseconds for some form of user input. And then the moment something is touched or pressed, or you get some push notification from a server, or the clock changes time, then the event that was triggered is actually handled in some way from left to right. And so when we're implementing a lot of the methods inside of these classes, especially these view controller classes, pretty much your app is otherwise just sitting in this event loop. And this is very common with most any GUI-based application, whether it's mobile or not. So if you're finding yourself a little confused diving into Project 3's implementation, and it would help to at least remember this kind of flowchart, complex though it looks at first glance, realize that pretty much all the magic happens once you reach that event loop. That's where your own code gets executed. All right, so recall that last week we took a look at this little application, which allowed me to type in my name at the top, allowed me to hit go, and then it would just say hello to me. And then we tried to clean it up a little bit so that after I dismissed the alert view window, it would actually remove whatever name I'd actually typed into the text box. Well, we did this all via, recall, Interface Builder. And Interface Builder is simply the GUI editor inside of Xcode that allows us to drag and drop and create UIs relatively easily. So recall that this is what our nib looked like. And I dragged and dropped a text field, I dragged and dropped a button, and then I configured it with the preferences on the right-hand side. But I also had to do some more interesting things. So the GUI is one thing, but how does the GUI actually talk to my code? Well, the code that we care about in many of these applications starting out are those files, of course, that we see up here. App delegate tends not to be all that interesting in terms of the guts of your program, because typically you'll implement the guts of your program in one or more view controllers. And so it's really these three files that collectively compose this application, the .h, the .m, and the nib file. So what kind of code did we write inside of the view controller class? And how did we connect that to the GUI so that one could talk to the other? What's some of the jargon here or tricks that we used? So I touch a button in the UI. I click go with my finger. What happened? Yeah?
Triggers an IB action.
OK, so it triggers an IB action. So that's an event. Button, what was it? Touch up inside is the event that Apple calls the touching inside of a button and lifting your finger. So that triggered an action. That is the invocation of a method. And that method was implemented in viewController.m. So IB action is just this preprocessor directive that flags a method as being an event handler, something that can be invoked by way of Interface Builder. So if I scroll over to my UI, and I forget, honestly, what we did last week, I have no idea how this thing's wired up with those little blue lines, you can go ahead and control-click or right-click on any of the UI elements, and most of this is blank, but there are two things here. So did end on exit for the tech. Actually, let's do the button first. So if I right-click or control-click there, there's only one thing of interest. Upon touching up inside, it should pass the go message to file's owner, but who's the file's owner? Main view controller. So it's an instance of the main view controller class. And file's owner then refers to the .m file more concretely. So let's take a look at this go method. If I scroll over to my .m file and I scroll down, there's some distractions here until I get to the go method, and this is what I did. And an IB action always follows this paradigm where the return type is IB action, capitalized as such, but recall that that's just a type def in C terms to what keyword? It's just void. It means this method returns nothing. But again, IB action is a preprocessor directive that's in there, or actually it's implemented by way of a preprocessor directive, a macro, so that Xcode realizes, oh, this is one of the things I should show in those little gray pop-up menus when the user tries to drag or control-click. All right, so ID and sender. So sender is going to refer to whom in the context of this method's invocation? the button. So the button is an object. It is a UI button object. And as an aside, that's a class that descends from a more generic class called UI view. So there's a little bit of hierarchy there. So the sender is that button object. So a pointer there too. But what does ID represent? Or what is it? So it's a pointer. Right? It's kind of like a void star pointer, if you think back to C, but it's a little more versatile than that. It can actually be nil. And in this case, it's not strictly necessary to say ID. If you know that the thing that's going to be sent to this message is a UI button, you can absolutely hard code UI button star. And the advantage of that is that you don't have to do a typecast later. So for instance, if later in this code I wanted to pass in I wanted to call a method on that button, which I don't. We're not doing anything with the button once it's touched. But if I wanted to call a method associated with that button, but it was just of type ID, the compiler